Hello everyone. I am deeply sorry and do apologize for not being able to attend the final presentation meetings, but I greatly appreciate this opportunity and this extra chance to properly complete my capstone project because I really have enjoyed this professional education course and have learned so much throughout my time studying and working with data science. So without further ado, my name is Abhiram Agina and I'm presenting my final capstone report upon regression analysis for used car price prediction. To begin, I will discuss the executive summary. So the problem presented within this project is that the used car market in India is rapidly growing, but it does contain great uncertainties in both pricing and supply. This uncertainty places used car sellers in an incredibly difficult and uncomfortable situation, as they are unable to accurately predict the value of a used car, which will further hinder their ability to receive accurate or fair compensation when selling a used car. Our intended goal with this project is to develop an effective pricing model that can predict the price of used cars with significant certainty based upon a series of known attributes, and developing this model will protect the used car market as well as its sellers. Our key takeaways and basic concepts from this project have been that we can use the random forest regression model approach along with basic data preprocessing, feature engineering, and missing value treatment, and model tuning in order to effectively predict the used car price in this project. Each potential solution is compared with one another in order to identify the most suitable approach. And being that it was the random forest model, this random forest model was then tuned through grid search cross-validation. Overall, our model was developed through a dataset of 7,253 used car entries, and this set was split into a training and testing dataset through a 70-30% split. Our model's results expressed an initial training accuracy of around 97.72% and a testing accuracy of 85.17%. And after tuning achieved a training accuracy of 96.96% and a testing accuracy of 86.12%. So through our developed model, we have identified the features of power, year, engine, kilometers driven, and mileage to be most significant. And ultimately, based upon our key takeaways and promising results, our next steps are to eliminate the remaining error, however small, from our model. So now I will move on to our problem and solution summary. So through the use of data science, we must build a regression pricing model that utilizes a used car dataset containing the attributes of serial number, brand and model name, selling location, manufacturing year, total kilometers driven, fuel used, transmission, ownership, standard mileage offered, engine, power, number of seats, and the price of a new car of the same model in order to provide an accurate prediction of the used car's value. And to develop this model, we must identify and utilize the most important features within the used car dataset. So, initially, before attempting to develop any sort of successful used car pricing regression model, it was imperative to effectively cleanse and organize our data, and this ultimately represents the feature engineering and missing value treatment step within our process. So, one example of this would be that due to the many unique car names within our set, the name feature was then re-engineered to be separated into brand and model features. And you can see within our graph that these are the various brand names and it's a much smaller subset. Missing value treatment was also completed for the seats, mileage, engine, power, new price, and price features. And for each of these features, median value imputation was used for our missing values. Subsequently, I developed and tested 3 regression models, and these would be our linear regression model, decision tree regression model, and our random forest regression model. And after creation, these models were tested and tuned for accuracy with the testing data and compared between each other. And based on this, we must identify the most accurate and applicable regression model for used car pricing. And based upon these results, it's evident that the hyper-tuned random forest model is performing the best and is most appropriate for our real world use. And through the image you can just see the results of linear regression, our decision tree, our tuned decision tree using grid search cross-validation, random forest, and our tuned random forest once again using grid search cross-validation. So why is this a valid solution that is likely to solve our problem? So the selected solution, ultimately being random forest regression model, is most ideal because it works well with both continuous variables and regression analysis, that it allows for nonlinear solutions unlike linear regression, making it much more applicable to real-life scenarios, and that it requires minimal pre-processing and data augmentation. So although this model is not perfect, we can optimize and utilize this model further for more data collection and increased random forest tuning. So a basic proposed solution model begins with our used car pricing data being collected, and then through some basic pre-processing of our data, and then followed by feature engineering and missing value treatment, which we showed a little bit of earlier, and then random tree regression model creation and subsequent tuning through grid search cross-validation. And ultimately, these steps result in an accurate price analysis prediction of a used car. So what are our recommendations for implementation? So key actionables include that our used car price prediction model is intended to aid used car sellers and ensure that they are receiving just compensation for their used vehicles. And currently our model is able to accurately predict and analyze the value of a used car. However, there does still exist a slight percentage of error where a used car could be potentially incorrectly predicted. And the reduction of this error percentage to 0 is of utmost importance and our number one goal moving forward. The time taken to develop an accurate random forest regression model should also be reduced, as it does take a significant amount of time to develop this model. These improvements will allow for the model to have an immediate and profound impact throughout the business. And furthermore, when implementing our solution, we can also look to maximize the profit for used car sellers and their businesses. So one example of this would be bringing in more first owner cars, bringing in more automatic transmission cars, high engine powered cars, and particularly sell these cars in southern city markets. So through this, you're more inclined to maximize your profit, but to truly maximize profitability within the used car market in India, we must collect a lot more data regarding the used car market, and then this data can then be analyzed. And lastly, what are key risks and challenges? So one major risk of this type of project is the potential to misinterpret the data given and inaccurately predict the value of one's used car. So this failing within our model could potentially lead to massive financial losses for both individuals and businesses, significantly damaging the growing used car market within India. And to combat this risk, it is necessary to gather more data surrounding used cars and their value such that our model can accurately and effectively predict going forward. Process to ensure the credibility of our model would be to corroborate our results with a certified car value assessor, right? And relating to our model's risks, a significant challenge would be the collection and processing and cleansing of our data. And this would allow for our random forest regression model to gather an eclectic database suited to predict the rarest and most unique of cars. And this would also include gaining information on all forms of car brands and models, and ultimately include expanding our database to include more features and more refined information such as exterior color, interior material, and even various amenities that exist throughout the vehicle, such as radio. So that concludes ultimately my regression project and my capstone for this course, and I've really truly appreciated this opportunity, and I would like to personally thank the Great Learning and MIT ADSP faculty for being so considerate and allowing me to make up this project through a video form. So thank you,